Let's discuss about chemical analysis. In this chapter, we are going to learn about identifying metal cations using flame test, use precipitation reaction to identify aqueous cations, discover chemical analysis techniques for detecting anions, learn gas identification methods, understand acid-base titration as quantitative analysis, recognize titration endpoint indicators. Let's talk about chemical analysis fundamentals. Purpose of chemical analysis. The goal is detect substances in water, soil and air quickly and accurately. Critical for identifying potentially harmful substances. Types of test. Qualitative. Yes, no answers about substance presence. Quantitative, precise measurement of substance amount. Bottled water analysis. Mineral composition. Minerals dissolve metal compounds from rock interactions. Composition cation, metalline plus anion, non-metalline. Health considerations. Some minerals beneficial. High concentrations can be toxic. Example, high potassium can cause hyperkalemia. Now, anion detection test. Sulfate ions. Test reagent. Acidified barium nitrate solution. Result, white barium sulfate precipitate. Caution, carbonate ions can interfere with test. Learn, and the outcomes are very important for the examination perspective. Next we have sulfite ion, SO3 2 minus power. So test method, oxidation using transition metal compounds. Typical reagent used, acidified potassium manganate 7. Indicator, color change from purple to colorless. Nitrate ion, NO3 minus. Test procedure. Add sodium hydroxide, add aluminium foil, heat gently. Chemical reaction, reduction to ammonia. Confirmation, blue litmus paper test. Gas identification technique. Number 1, hydrogen. Test, squeaky pop test. Procedure, lighted splint near gas source. Characteristics, rapid combustion with distinctive sound. For oxygen, test is glowing splint relight test. Indicator, rapid combustion in pure oxygen. Then we have carbon dioxide test, lime water, calcium hydroxide solution. Result, cloudy, milky appearance due to calcium carbonate formation. Practical consideration, test limitations, potential interference, carbonate ions. Then we have precision required, correct acid reagent selection, careful experimental techniques. Next we have chemical analysis. Here we have acid-base titration. Key concepts. Purpose, determine the point of neutralization between an acid and an alkali. Essential equipment, burette, conical flask, indicator. What are indicators? Definition, chemicals that change color at the reaction's endpoint. Notable indicators include methyl orange, color change yellow basic to red acetic. Then thymophthalein, color change blue basic to colorless, which shows acidic in nature. Precise measurement techniques, we have burette reading, position eye horizontally to meniscus. Read from base of meniscus. Accuracy to plus minus 0.05 centimeter cube is okay. Record start and end volumes. Now, let's talk about titration procedure. Conduct trial pilot run to estimate titer volume. Add acid dropwise near end point. Swirl conical flask to ensure complete mixing. Repeat until 3 consecutive results within plus minus 0.10 centimeter cube. Then we have titration types. Acid solution with alkali. Acid solution with insoluble base. Quantitative analysis method. Chemical detection techniques. Cation detection. Flame test colors. Metal ion and the flame color. If it is lithium, the color will be red. For sodium, the color will be yellow. For potassium, the color will be lilac. For calcium, the color will be orange red. For barium, the color will be light green. For copper, the color will be blue green. Some precipitation tests use sodium hydroxide or ammonia solution. Test for metal ions, these all you can use. Anion detection, carbonates ions, effervescence with dilute acid. For halide ions, precipitation with acidified silver nitrate. Very important to learn and memorize. Sulfate ion, precipitation with acidified barium nitrate. If there is sulfite ion, redox reaction with potassium manganate 7. Nitrate ion, redox reaction with aluminium. Now we have gas detection tests. Common gas test, hydrogen, squeaky pop with lit splint. Oxygen, relight glowing splint. Carbon dioxide turns lime water milky. Chlorine bleaches damp litmus paper. Ammonia turns red litmus paper blue. And if it is sulfur dioxide, it turns potassium manganate 7 from purple to colorless. Some memorization technique, repeat, practice, create mnemonics, develop storytelling methods. Some recommended approach, use multiple learning strategies, assess effectiveness of each method, check yourself, make personalized learning technique, repeat, write, make it in a form of an activity so that you can learn it easily. Let's continue with our chemical analysis. Identifying metal ions, flame test methods. Here we have identifying metal ion through characteristic flame color characteristics. So in metal ion lithium, the flame color will be red. For sodium, the flame color will be yellow. For potassium, lilac. Calcium, orange red. And for copper too, we have blue green color. Some experimental technique, use nichrome wire or wooden splint dipped in metal ion solution. Carefully place in Bunsen burner flame. Caution, avoid burning the splint as yellow flame will invalidate results. Observe characteristic color produced. Precipitation reaction with sodium hydroxide. Key concepts, precipitation reaction form insoluble metal oxide, particularly useful for transition metal ion, less effective for group 1 and group 2 metals. Precipitation results with NaOH, unique characteristics for different ions. For aluminium, white precipitate that redissolves, calcium, white precipitate that remains insoluble. For copper 2, light blue precipitate, insoluble, very important for learning. For iron, Fe2 plus, green precipitate turns brown over time. Iron, red brown precipitate, zinc, white precipitate that redissolves. Now let's talk about precipitation reaction with ammonia solution NH3. Distinctive features, produces similar initial reactions to NaOH, creates slightly different results with excess solution. Ammonia solution precipitation characteristics. Zinc aluminium ion, initial white precipitate. Zinc precipitate dissolves in excess. Aluminium precipitate remain insoluble. Copper 2 ions, initial pale blue precipitate. Very important for exam to learn. Redissolve in excess to form dark blue solution. Then we have experimental skills for cation identification. Required materials: test tube rack, Bunsen burner, measuring cylinder, dropping pipette. 2 to 3 materials if you can learn better for examination perspective: sodium hydroxide solution, ammonia solution, and various metal ions test samples. Some safety precautions: wear eye protection, avoid chemical ingestion, wash hand after handling, rinse skin immediately if contact occurs. Some key terminologies for you to learn: precipitate are insoluble salts and they are formed during precipitation reactions. Some symbols: S for solid, L for liquid, G for gas, AQ for aqueous solution. With this, we have finished our this chapter. See you in our next subject.